Well, welcome back. So you see a pattern unfolding here with our videos. We're going to do the integral of sine squared theta d theta, and this, just like the previous one, will be another look at what we've done already. So we've seen this 2 videos ago, and in fact, if you look at the last video, what we're going to develop here in this video is analogous to that one. The only difference being is that now this is sine squared theta. But we're basically using the same ingredients, okay? So we have the integration by parts. Let's remind ourselves, I've asked us numerous times, let's memorize this. Integral of u dv equals u times v minus the integral of v du. We also were asked to memorize sine of a plus or minus b. That's sine of a cos of b plus or minus sine of b cos of a. So in particular, if you have sine of theta plus theta, that's going to be sine of theta cos of theta plus sine of theta cos of theta. That's to say sine of 2 theta is equal to 2 times sine of theta cos of theta. And like I did in the last video, we're going to just go ahead and call this I, the integral of sine squared theta d theta that we're interested in. And we're going to go ahead and write this as the integral of sine theta times sine theta d theta. Once again, we don't have too many options here. We're going to call this first term the u. So the balance of this sine theta d theta is dv. That's just following the pattern of the IBPS. And so we get, first of all, when I apply the integration by parts, we get u times v. Okay, we need to develop u and dv and all of that. Okay, so u is sine of theta du is equal to cos theta d theta, and dv is sine of theta d theta. So if you integrate both sides of that, you get v is equal to minus cos of theta. And so, like I was beginning to say, u times v, which is the product of that on the first term on the right hand side of that equality, you get the product of these two. So that's going to be a minus sine theta cos of theta minus the integral of v du. That's going to be a minus cos theta. So that's the product of these two guys. Minus cos theta times cos theta d theta. That's going to equal minus sine theta cos theta. Minus times minus is a plus. Integral of cos squared theta d theta. And we now sub in our most used trig identity of them all, which says that sine squared theta plus cos squared theta is equal to 1. That means that what I just encircled there, that cos squared theta is 1 minus sine squared theta. So let's do that. We have, so minus sine theta cos theta plus the integral of 1 minus sine squared theta d theta. And then we get minus sine theta cos theta plus the integral of d theta when I distribute, minus the integral of sine squared theta d theta. And once again, we recognize this integral to just be I. Okay, and I'm going to go ahead and take this I to the other side. So I'm going to get, in fact, 2i's like we did in the last video. Alright, so we get 2i's on the left-hand side is equal to theta, which is the result of integrating d theta, minus sine of theta cos of theta. And then we're going to also pick up a constant of integration, which we called c hat. Okay. And then if I divide both sides by 2, I find that I, which is what I was after, is 1/2 theta minus 1/2 of sine of theta cos of theta plus 1/2 of c hat we'll just call c. And so the last thing that we did in the last video, I'm just basically, it's a cookie cutter pattern that we're looking at here. So we noticed that up here what we did is that sine times cos is equal to 1/2 of sine of the double angle. So let's sub that in here. And so to summarize then, I have therefore the integral of sine squared theta d theta is equal to 1/2 of theta minus 1/2 of sine theta cos theta plus a constant of integration, or if we make that substitution, we can write this as 1/2 theta minus 1/2 times 1/2 is 1/4 times sine of the double angle plus some constant of integration. And so there is our other look at integrating sine squared theta d theta. Thanks for watching. We will see you in a future video.